Now let's begin our in-class hands-on example, which is the virtual drive test for the scenario. In this example, we will first load an urban database that will include the terrain information as well. We shall define a base station and run a regular propagation simulation with base station as the transmitter. Next, we will define the trajectory or the path of interest where virtual drive test will be performed. Once the trajectory is defined, we will define an antenna pattern for the mobile station or the receiver. Use run mobile station to determine the impact of the receiver pattern on the received signal along the route. So let's start with the first step. The material required to perform this example is provided with the training files. The files include two antenna patterns that are as shown on the screen. The .apb files represent 3D antenna pattern files in binary. The beam12db.apb and sector antenna 1.apb files will be used as receiver and transmitter. You also see munique.oib and munique.tdb files that include the pre-processed urban database and the topography database, that is .tdb, that will be used for this example. The first step is to open the FECO launcher, as you can see on the screen, that contains both FECO and WinProp installed together. We will first launch ProMan, that is the propagation manager, and create a new project. As propagation manager opens up, you will see we will click on file and create a new project. From the drop down window, we will select propagation analysis without network planning and then select urban scenarios, which includes vector data for urban buildings and database for topography data. Check the option for use only pre-processed vector databases, since we already have a munique.oib file which is a pre-processed database. Click on select and browse to the location where you have the OIB file. Select it and click on open. Click on OK and accept the default height as 1.5 meters. Please note that the height can always be modified via display menu later. We click on OK to see our database is now loaded. We can go to the 3D view to observe the database. Please note that this database is pre-processed, so topography data is already added in Wallman and then pre-processed. There are various ways you can observe the topography data in ProMan. To change visual settings, you can go to Settings, Local Settings, Display of Data, and then go to the Palette tab and select any one of the options. For now, Green Meadow was selected, and that's why we see the visual data in a particular format. If you click on Rainbow Bright, you will see a different type of visual data. I will once again go to the local settings and change it to Green Meadow and click on OK. The next step is to save the project and name it as Virtual Drive Test 1 and click on Save. Our next step is to define a base station site. This can be done using two options. You can either go to Project, edit project parameters, and then go to Sites and click on Add. If you have multiple sites, you can also define the initial properties of new objects or default properties of cells or sector antennas. All these can be done over here. The second way of doing this is using an option on the left toolbar that is called Set Site. You can click on Set Site and select the type of the transmitter. We will select site with sectors and select 3-sector site and then click on OK. We'll see that the cursor changes to a circle with the center to place the site at a particular location. Users can choose a site of their own choice. Once we select a location for site 1, 3-sector antennas will be defined with different azimuth values. We will individually change the properties of each antenna as suggested by the instructions. After double clicking on antenna 1, I will first modify the frequency to 1800 MHz. We will leave the transmitting power to 10 watts. We will change the height from 15 meters to 40 meters and assign a directional sector antenna by clicking on Select. We will add sector antenna 1, click on Open, and then click on OK. That will change the properties of antenna 1. Similarly, for antenna 2, we will repeat those steps. And click on OK. For antenna 3, we will change the settings and assign the antenna pattern. Once we click on OK, a 3-sector site is now defined at the desired location. There are other options to erase the site or edit the site in the toolbar over here. As you can see, just below the Set Site option, you have option to erase the site. If you want to edit a particular site, it can be done from project parameters as well as by selecting an option from here. You can also move the antenna by a tool called Site Move. So all these options are available in project parameters or on the left of the toolbar over here. Currently the Set Site option is toggled on, and that's why my cursor is still the same. I can click on it to toggle it off. Now we can go to the 3D database to observe and confirm that our transmitter is above the buildings. If in your case it is not, you can change the z coordinates from 40 meters to some higher value. Now we shall come out of the 3D view and click on project, click on edit project parameter. However, the shortcut for project parameters is the first option on the left hand side of the toolbar as shown. We will see that the resolution and the prediction height are predefined since we are using a pre-processed database. If we now move on to the second tab, that is the Propagation tab, here we can request for particular outputs that are available. You can select additional output of results to be stored in an ASCII file, which is the str file. Sites and building data are already defined. We will select channel impulse response and propagation paths in addition to received power, which is by default selected. Users can also add any other kind of requests if they want to from here. We will move on to the next tab, that is the sites tab. We see our site defined over here. The building data is already defined. Finally, we can move on to the Computation tab. You see that by default, intelligent ray tracing is activated or selected as we will use a pre-processed database. Optionally, user can click on settings and access settings that include extra reflections. For now, we will stick with the default setting and click on OK. We shall now save this project and run propagation analysis. Once again, propagation analysis can be accessed by two ways. On the left hand side of the toolbar over here, we have an option called Run Pro, which can be directly used for running propagation analysis. The same option can be accessed from Computation tab and clicking on the first option, that is Propagation Compute All. We see that a new execution window opens up with three different antennas. Propagation analysis will be done for all these three different antennas, and the results will be available as soon as the simulation is complete. We can see individual power levels due to each antenna in the 2D view. You can also look at this result in 3D view. If you click on the 3D option, we can use the display ray of path option to look at the plotted rays. You can find this option on the right hand side toolbar. We can click on different locations and see how the rays are interacting between the transmitter and the receiver location. If you click on it and then go to the 3D view, we can see how different paths are taken into consideration while reaching a receiver point with the colored signal levels represented in the rays. We can come out of the 3D view. Now, to consider the receiving antenna pattern or receiver antenna in a given project, we can go to Edit Project Parameters again and go to Propagation tab. When we are in Propagation tab, we check the box which says consider antenna for MS, which is mobile station, or in simple terms receiving antenna. I will check these options and click on Edit Parameters. By default, we will see that the type of receiver antenna is selected as single antenna element, and current radiation pattern is omnidirectional, which means that we have not defined any antenna pattern at this point. To add a receiving antenna pattern, we will double click on omnidirectional, click on browse and select beam 12 dB and click on open. We will select or accept all default settings for antenna adjustment and polarization and click on OK. Please note that the azimuth and the tilt rotate of the imported pattern can be done if desired. If you choose azimuth equal to 0, then 0 degrees from the imported pattern will be pointed in the positive x direction, which is east on the map. If you choose azimuth equal to 90 degrees, then the 0 degree from the imported pattern will point in the positive y direction, which is the north of the map. Propagation Manager offers multiple ways you can define the receiving element or the receiving antenna. You can also add a uniform vertical rectangular antenna array, or a linear array, or a circular array. You can also have individual location offset for each element. So this is how it can be defined. For simplicity, we will just stick with single antenna element. There are some more options available as far as channel data is concerned, or what kind of results user needs to see. So now that we have defined the receiving antenna, we will click on OK and then click on OK again. We will see that the results will now be automatically deleted since we have changed the settings. Once again, we will save the project by going to File and Save Project. We will now run the propagation analysis again by clicking on Overwrite Already Existing Results. Click on OK. We shall now run the mobile station, which is run MS, to take receiving pattern into consideration. Once we click on run MS, the simulation is very quick, and now we have result for power and power MS, which is the receiving antenna. The power for the transmitter would not change, but if we look at the received power considering the receiving antenna, we see that the results are now different than before. Your results will almost certainly be different since it would depend on the exact location of the transmitter. Now our next step is to define the virtual test route. This can be done by going to Project, Prediction Area, Prediction Trajectories, or you can use the option on the left of the toolbar over here. Click on that. We can now click on points of the trajectory with left mouse button. Right mouse click will terminate the route definition, which means it will not be considering an additional point. Users can choose their own path. I am randomly selecting a path using left mouse click as you see on the screen. With the right mouse click, I terminated the definition of the path. You can have more than one trajectories. Once we go to edit project parameters, we will see that the trajectory will be defined. Currently, the trajectory defined has 15 points. You can add, import, and delete. If you double click on the trajectory, you can change the coordinates, which means you can also change the z height by changing the coordinate. We shall now edit the parameters of the mobile station by going to project parameters, double click on the antenna pattern or antenna element and set azimuth to 90 degrees. Now we click on OK and click on OK again. We will now save the project and then use Run Pro to simulate the propagation again. It will now be done on a smaller area, enough to cover the trajectory. Use Run Mobile Station or Run MS to simulate mobile station, now moving along the trajectory. Receiver antenna pattern makes turns along the trajectory as if mounted on a vehicle that drives the trajectory. We shall now look at the propagation results on the path from different antennas. You can observe the received power levels on different locations while the receiving pattern is mounted on a moving object. Your results may differ depending on the location of the transmitter and also the path that you have defined. You can optionally try a few other routes and other antenna orientations to look at the different results. You can also look at the results in the 3D view and see that the received power is maximum of -70 dBm, which is at the locations which are very close to the transmitter. This is how one can perform virtual drive test like applications using WinProp. With this, we are at the end of today's session. Thank you very much for viewing this video.